democratizing is very important to us. It's all children. So it's the inclusion children, it's the periphery children, it's the children who are very fortunate to have families who have means or have families. In America, we have many, many children without full families. And in fact, in our cities, more without than with. It's also all of this. These are the words of STEM. When I asked 8th graders, I said, what's STEM? I want you to do a wordle. I'm going to do a wordle. What are the words? That is their words. Take a moment and look. They're spot on, they're right. Couldn't say it better. That's an 8th grade's vision. It's our vision. Notice how large creativity is. It's not just technology. It's not just innovate. It is innovate. Big way innovate. And resilience. 8th graders' resilience? That's a big word. But that's meaningful to them. They hear it. They know what it means. Transform. Breakthrough. The breakthrough part I thought was interesting too. STEM for all. Now, STEM now, and what you're doing is not what we did 10 years ago. STEM, science, technology, engineering, and math. Notice there's no period, S period, T period, no. Because it's cross-cutting. And we said we wanted it that way. But 10 years ago, we talked about education. Didn't talk about work. Didn't talk about economic development. We said how our children learn in our science classes, in our math classes mattered, and that there was technology. Now it is transdisciplinary, not interdisciplinary. Difference? There's a big difference. Big difference is it's not just throwing everything together and mixing it up, and we've got STEM. It drives from the problem. It drives, if the problem says we're first biology, then we have some physics, and we have some math, and we have some technology, that's transdisciplinary. Not because you stuff it in there, and then we have to have the interdisciplinary. So it's a change of words for this decade. The second, it is driven by the engineering design process, solving problems. Our children do not have the luxury in America, in Israel, in Egypt, in Mexico, in Puerto Rico. They do not have the luxury to study without solving community problems. Our problems need their smarts. And looking at what's going on here and seeing what you're doing and talking with you, you understand this. The world around us doesn't get that. And that's really critical. And parts of Israel don't get that. If you go to Beersheba, you might see some of it. But if you go to other places, you're not going to see that. It aligns with post-secondary education. They are going to the IDF, but they're going to spend a lifetime of learning. It's a lifetime of learning. It connects, STEM connects to that. We have to create a workforce. This is an issue in Israel, and I'll show you what the statistics are here. And ensure economic development. That's how do we prosper? How do they prosper in Israel and not show up in America? So that there's nobody, so the brains are in America from Israel rather than in Israel. That's not what we want. That's not what you want. So STEM education in action in the 21st century, our schools look differently. Learning spaces look different, like here, like Tech Startup. It's beautiful. It's a beautiful thing. And that they're flexible. Flexibility is a really important word in STEM, for STEM education for all of us. At all age groups, even our little folk. That's really quite important. They happen everywhere in virtual spaces. They don't have to be in a classroom. They don't have to be in a school. They can be anywhere as long as they are connected virtually. And The connectivity is important. In our city, in Cleveland, 40% of the children are not connected in inner city Cleveland. And that is a real struggle. So for STEM to be really fabulous at home, they have to be connected. So that's what we're driving. That's our year this year. That's our goal in 2018. They learn the language of coding, computer science, computational thinking is STEM. It isn't computer science and computational thinking and STEM. It is the same thing. And coding is not enough because our robots are going to code for us. So our children need to understand the language, but they may not have to understand all the coding. That's a really important point because we're spending a lot of time teaching kids coding and a lot of money. And when computational thinking is really as important. Digital fabrication, which you have here, they inspire creativity. They take what's up here and they make it work. So whether it's those boats that I saw downstairs or the robots that I heard about earlier from your children, about robots cleaning and sanitizing floors. I have to have one of those. I have to not leave without one. Those are brilliances. Those are brilliant. And they come because what's up here and that creativity and that knowledge and that drive have capability. Capability is so vital in STEM, and a pencil is not going to do it. And a calculator is not going to do it, and neither is a laptop. It has to go the next step. But you've understood that. You have that here. What does that look like in schools? And when some of you come to Cleveland, you'll see it's in many of our schools and sitting there as the laboratories. There's no turning back. There's absolutely no turning back. STEM is the future. So if that's true, we better get friendly with our machines and not be afraid of them. In America, we talk about AI, and everybody says, oh, AI, I'm not going to have a job. They're going to teach our children, we're not going to have teachers. Oh my goodness, I'm not worried about that in the least. I'm worried about the fact that we wouldn't understand this, that this would happen without our children, or happen without us as educators. We have to get on the program. They are there, and if our children are doing the robotics, and if this is what the future is, then as teachers, we've got to learn it. And it's hard. It's hard. When I came into the world, my freshman chemistry class, I went into my final, and they looked at me and they said, leave your calculator at the door. Bring your slide rule. That was a hunk of wood. What would happen if we said to our children right now, excuse me, you have to take your chemistry final with a slide rule? They would think that you walked out of 200 years ago. Things have changed, but what's important is that we as educators, we as teachers, have to be up with that. And the best part of what brings it to the classroom. There are many schools in America that have not progressed, and I'm sure, and Israel as well, but we know it. We know half the battle is knowing that the schools have not progressed, and what do we do about progressing the schools? We design for the future. We think about what's coming, not always what's here now. You have to think ahead in STEM. That's what we should do. And we do in America what's called education reform. Global landmark events, and we have a STEM education movement. That movement in education is now not just education. It's all about workforce, it's all about economic development. We are coming full circle in America. We ask lots of great questions that we have asked. Should we favor practices of content? What do we know that the kids should learn? There's just too much to jam it in class. What should they learn? What do we prepare students for college careers in the IDF? What does school do? What does the IDF do? What does post-secondary do? Making a whole system out of that. So STEM is continuous. What role does the ministry play? What role does local policy play? Can students take technical and applied and honors courses? In America, it took us a very long time to say that our vocational kids could take the same algebra as our academic kids. It's all algebra. It doesn't matter if you're going off to do a trade or if you're going off to four-year college. Same algebra. In America, it's one now. Important question. How do we measure student learning? You're measuring by test. When the British were here, way back when, the British handed you a system. And Israel, and Singapore, and Australia, and Egypt, and America all believed in tests. Enough. Enough. We have given enough tests. There have to be other ways, and there are other ways. And one of the things that STEM is starting to teach us all is of those other ways. It's not just STEM, but it is at least STEM in that other way. How do we align in order to maintain a global competitive edge? K-12, IDF, technical college, post-secondary, the four-year colleges, certificate programs, on and on and on. It's one child. How does that child learn and continue their life so they get to many professions? Do you know the statistic in America is today's fourth grader will see 30 different jobs because everything's changing. So it's no longer the 30 years on the one job, it's the 30 jobs, which might be 2 or 3 years, right? STEM education in action is honors courses, advanced, out of school, whole school models, which you'll get to see, MC squared, when you go to see the Mandel School as well, and workforce readiness, all together, not separate. But what do we need? How do we actually make this work? How does it work in Israel? How does it work in America to get industry and after school and arts and computer science? It's complicated. It's really complicated, right? It's not the same system. We need a new framework. We need a new model. We need a new way to make decisions. We need an architecture. That's the word. It isn't many, many more heaps of programs. More robotics programs, more after-school cars, more this, more that. We got lots of that. We don't have any way to bring it together and to really make a beautiful system out of it. Take the existing system and let it go and bring up the new system. So a new architecture has to support really grand challenges, problems of the world. Do you know the Millennium Challenges? Do you know this? Your country participated in this. Israel was a driver of this. What are the important questions to ask the world that need to be solved? Poverty, number one. Our children need to understand that. They need to have facility to be able to do that. And all these goals. Grand challenges, community need, innovations that advance global wellness. Whether or not a robot that cleans and sanitizes the floor is global wellness, I'm not so sure. However, it is the step to something. That certainly is. We need a STEM learning ecosystem. It doesn't say student. It doesn't say child. It says learner. And it says ecosystem. Biologists, biology. Biology, me, you, too? No. Seriously? Wow, that never happens. Okay? We know what an ecosystem is. An ecosystem is a series of relationships in which you learn to depend on each other, in which energy flows through. In a STEM learning ecosystem, which we're developing in America for the globe, you have homes, school, libraries, science centers, buildings like this, after school, in school, families, all together. And what are they doing together? They're making decisions together. They're educating together. We have one set of children in communities. If it's an after school that doesn't talk to school and STEM, then we have two different systems. If we add in buildings like this, that's number 3. If we add in faith-based, that's number 4. And if we have the family, that's 5. All touching the same children. Doesn't work. If we're all together and driving from learning outcomes, what do we want children to be able to learn and to demonstrate? Can't do it all, so what's the important part? That should be what it looks like, with all the energy and the flow of the ecosystem.